Okay, so in this video, let's wrap up our Python script for rendering all of our different passes by taking into account all of the various settings we need to make to set up for a diffuse pass, for a specular pass, and for a shadow pass. So I'm going to right click on our tool, come down to Edit Tool, and the first thing I'm going to do is build a new class. We've already got our render info class for storing some information on our renders. Let's build a class for storing some information on our lighting. So I'm going to create a class, and this class is going to be called Light Settings. And like with our render info class, we're going to have a constructor function. So def underscore underscore init underscore underscore self. And this function is going to initialize the various members that this class is going to have. And this class needs to store some parameters for our light. What parameters does it need to store? Well, let's jump over to our object context and hunt down a light. We said when we're talking about setting for different passes, we need to change diffuse contribution, specular contribution, and whether we have shadows. So we need to store the settings on our lights before we make any modifications as to, is diffuse checked, was specular checked, and what type of shadows do we have. It'd also be really useful to store the path to our light, so in this case /obj/bleach as bounce, since then when we go to reset those light settings we can simply grab that path to grab that node. So what we're going to have as members of our light settings is going to be a diffuse parameter, so self.diff, and we're going to default that out to a value of 0, 0 being diffuse is off, 1 being diffuse is checked on. We're going to have a self.specular parameter, again defaulting to 0, 0 being off, 1 being on. We're going to have a self.shadows parameter defaulting to 0. 0 means we don't have shadows. 1 would mean we have ray trace shadows, 2 would mean we have depth map shadows. And finally we're going to have a name parameter, which I'm going to default to an empty string. And this name parameter is going to store the path to the light that we represent. So now that we've got this class in place, we can go ahead and as we're down inside our render description file method, up under setup for render pass, we can go ahead and we can split the lights that we're passing in. And what do I mean by that? Well, let's hunt down our whiteboard. And where we're specifying lights, the argument for our lights command could be any number of lights, all space separated. And we want to deal, in this case, with each light individually because we need to go to each light, we need to store the parameters for that light, we then need to make modifications, do our render, and then come back and restore. So we need to deal with each light individually. To do that, we need to take this argument as a whole and break it up based on spaces, since these lights are going to be space separated. So we can take our lights parameter, which we know to be set under our render item as the .l member. We can take that and we can split it based on spaces, and if we store that into a new variable, that variable will be an array of our lights, one light per basically array index. So we're going to have our, make sure that's indented correctly, we're going to have a new variable called light list. We're going to take our render item.l and we're going to split this based on spaces, and to split based on spaces we can simply call split without passing it any arguments, any parameters, and by default it will split based on spaces, whereas earlier we called split, passed it space equals space as its argument. So this is going to take that light argument, which could be any number of lights space separated, it's going to break it down based on spaces, and each light is now going to exist in its own index in the array. I'm also going to create another array, and this is going to be an array of our light settings classes. One item is going to be created, one class instance in our array is going to be created for every light that we have. So we can have diffuse, specular, shadow, and name for every light that we have. So I'm going to start this out as an empty list. And so let's create a light settings list and start this out as an empty array. So to store our light settings and restore our light settings, it sounds like this is something that it would be good to break off and create in a new function, since it's a, it's a focused area that we need to work on. So I'm going to create two new functions for storing and restoring light settings. So let's define a store light settings function. And we're going to take in our light list, which if you recall is going to be our array of lights that we need to store. And we're also going to take in our light settings list, which is going to be our array of light settings classes, one item per light. And what we need to do, we need to loop through our light list. So for L in light list. And that's going to loop through our light list, and for each item in our light list, it will store that item into L and then execute the following code. So let's create a new instance of our light settings. So I'm going to call this new instance new entry. So new entry equals light settings. So that will create a new instance of that light settings class. And now we can start filling in information into that class. So the first thing we can do is we can construct the full path to that light. We know that our light's name is coming in, say, as something like bleachers top. And we know that we need a /obj/ in front of that light name to get the full path. So let's take our new entry name parameter and set that equal to /obj/ and append to that our light name, which is going to be stored in L, since our light list was our space separated. We separated our argument, broke it down based on spaces into our light list. So one item in that light list is going to be one light name. We can concatenate /obj/ to the front of that. That will generate the entire path for the light. Now that we have that name, it's easier to go ahead and actually grab the node, the light node itself. So I'm going to create a new variable called L node representing that node. And I'm going to use the who.node command to go ahead and grab the node represented by new entry.name. So now that we've got the path, we can pass that path to who.node. That will return the light node itself. Once we have that light node, we can go ahead and evaluate some of the parameters of that light node to find out, was diffuse checked, was specular checked, and what shadow type do we have. And we can take the results of that and store them into the 3 remaining members of our light settings class that we just generated. So our new entries diffuse, we can set to our L node .evalPalm. And which parameter do we need to evaluate? Well, let's jump over to Houdini, and we can see that the parameter we want to evaluate is this diffuse contribution, which is the parameter light_contrib_diff. So we're going to evaluate the parameter light_contrib_diff, and that's going to return to us whether that diffuse contribution checkbox was checked or not checked, and store it into newEntry.def. We can repeat that for our specular, so newEntry.spec equals lnode.evalPalm light_contrib_spec. Again, if we jump over to our light, we can hover over the specular contribution and see that the parameter is called light_contrib_spec. So now we're storing whether this checkbox is checked or unchecked. Finally, our new entry.shad for our shadows can be set to lnode.evalPalm, and in this case we want to grab this shadow type parameter, which is shadow_type. So we can grab our shadow_type parameter. Now that we've stored all those into that entry, we need to put that entry into our light settings list, our array of light settings classes. So we can simply grab our light settings list and tell it to append our new entry. So we're going to loop through all of our lights, and for every light we're going to go ahead, generate the full path to that light, save it in name. With that full path we can grab the node itself. Once we have the node, we can evaluate whether it's contributing to diffuse, contributing to specular, and what shadow type it has. Again, storing that information into the relative members of our new entry. Once we have all of that, we can push that new entry into our light settings list. So what we're going to do is loop through for every light, building up one of these light settings classes for each light, storing it into this list. And then when we exit the store light settings function, this light settings list is now going to have an array of light settings classes, one for each light, all set with that light's parameters. And that means that we can come back in a second and restore those parameters using this array. So let's write the function that's going to restore those parameters now. So we can call this restore light settings. Again, this time we only need to take in the light settings list, and that's because we've already got the full path to our light stored within our light settings, so we can get access to the node, and with access to the node we can then set its light contrib diff to whatever we had stored in diff, its light contrib spec to whatever we had stored in spec, and its shadow type to whatever we had stored in shadow. So we need to loop through every entry in our light settings list. So for L in light settings list, we're going to grab the light node represented by L, so that's going to equal who.node L.name. And once we have that, we can say L node dot palm, and we can grab our light underscore contrib diff, and we can set that equal to l.diff. So whatever we stored for that light before we changed any settings, we're now setting back. The same for our specular, so lnode.palm light underscore contrib spec dot set l.spec, and finally the same for our shadow, so lnode.palm shadow type dot set to our l.shad. So now we have a system whereby we can come in and we can store all of our light settings, and we can come in and we can restore all of those light settings. It now means that we can go ahead and store them, change them, and restore them back after the render. So let's go up here to where we've created our light list and we created our light settings list, and let's actually call on our store light settings functionality. So we're going to store our light settings, passing in our light list and our light settings list. As you can see, store light settings needs a light list and a light settings list. Then after we've changed our settings and we've done our render, we can go ahead and restore our light settings. So we're going to call on restore light settings, passing in just our light settings list. So now all we actually need to do is go ahead and set up the various changes we need to make based on if we're rendering a diffuse pass, a specular pass, or a shadow pass. And to know whether we're rendering a diffuse pass, specular pass, or shadow pass, we stored the pass type that we specified with the pass command in our render description. We stored that into the p member of our current render item. So let's see if our render item .p is equal to diffuse. If that is the case, we're going to need to create a diffuse pass. Otherwise, so lf render item.p is equal to specular. We need to go ahead and set up for a specular pass. Else if, so lf render item.p is equal to shadow, we need to go ahead and set up for a shadow pass. Else, we've obviously fed into our render description a pass type that's not supported, so let's print out that %s is not a supported render pass type, percentage, and inside here we can specify our render item.p. So that take whatever pass we've actually called, put that into %s, so it will say, for example, if you tried to create a pass called Steve, it would say Steve is not a supported render type. And we'll skip actually rendering that item by calling on continue, so we'll loop back up and grab the next render item in our render list. So now we need to go in and actually block in these if statements. So what do we need to do to set up for a diffuse pass? Well, we need to loop through all of those lights that we've got in our light list. We need to go ahead and grab the node for those lights, and with the node for those lights, we need to set our diffuse to 1, we need to set our specular to 0, and we need to set our shadow type to 0, so we're only emitting diffuse. So for L in light list, so we're going to loop through our light list, and for every entry we're going to store that into L, then execute this code. We can get our light name, as we saw earlier, by concatenating /obj with L, which is the name of our light. Once we have that, we can get our light node, so lnode equals who.node light name. Once we have the node, we can now set some parameters. So lnode.palm, the light contrib diff parameter we want to set to 1. We want to make sure diffuse is enabled. Our light contrib spec parameter we want to make sure is disabled, so set to 0. And finally, we also want to make sure that our shadow type is also set to 0, 0 being no shadows. So 0, 1, and 2, 0 being no shadows. So we've disabled shadows, we've disabled specular, we've enabled diffuse. They be the settings we need to make on every single light in our light list in order to render a diffuse pass. We also need to go ahead and set up for our specular pass. So again, we need to loop through all of our lights, and we need to set settings for these lights. So what if we were to select all of this and middle click, actually undo that. Explosion. That's okay, it overwrote the if statement, so we'll just bring that back. So elif render item dot p equals specular. Huh. Oh, that's where it went. It went above the if statement. That's cool. As I get confused. Let's grab all of that and middle click to paste that down here. Fantastic. So for L in light list, again, we're looping through all our lights. We need to be setting for a specular path, so we grab our light object's name, we grab the node based on that name, and then we need to make sure we set our diffuse. In this case, we're setting it to 0. We need to set our specular, in this case, to 1, and again, our shadows to 0. Finally, if we grab this again and jump down for our shadow, we need to loop through all of our lights for our shadow, again, grabbing the light name. We need to make sure that our diffuse is set to 1. If you recall, we need to make sure we are emitting diffuse in order to get shadows, because otherwise it's going to be as if the light is turned off. We need to make sure our specular is set to 0, and we don't want to mess with the shadow type because we don't know if we're set to ray trace shadows or depth map shadows. We also need to go ahead and set our render node to use the shadow take. So after we've looped through for all our lights, we need to go ahead and set the render to use the shadow take. And when we created that take, we made sure that we named it specifically shadow take, shadow capital T for take. And that's because we're now going to call on the shadow take specifically with that spelling. So if you've named your take something different, you need to make sure you make that modification here inside your script. So we're going to be calling on our node dot parameter. The parameter we're going to set is take. Which parameter is this? Let me just make sure the indentation there is correct. Fantastic. This is if we jump over to our outputs and grab our render node. The take parameter is the render with take. We want to set this from current over to using the shadow take when we render. So we're going to set the parameter, the take parameter, we're going to set that to shadow take. So by setting it to shadow take, we're going to come over here and instead of it being current, it's now going to be shadow take, which means that when we fire off the render, we're going to be rendering using shadows. However, we've now just made a modification to our render node that would mean if we were to loop through and hit another render, we'd come in and we'd render our diffuse also using the shadow take, or we'd render our specular also using the shadow take. So up here in diffuse and specular, we need to make sure that after we've looped through for all our lights, we set our render node's take parameter back to whatever it was, well, back to what it is by default, which is current, which means it's going to be whichever take we have specified within Houdini. So to set it to the current parameter, we need to set it to underscore current underscore. And we need to do this for both diffuse and specular. So our node dot param take dot set underscore current underscore. And with that, we should now have everything in place for our render script. So I guess we should go ahead and do a test render of a couple of passes maybe, just to make sure everything's working.
Okay.
So to do that, I'm going to accept the script, and we've got this temp description.txt.
Actually, let's go ahead and do this. Let's go ahead and put that on the next video.
Sure.
Okay, so that's going to wrap up this video. Thanks a lot.